Hello students, welcome back. I am Rinkesa, a mathematics teacher at Lux School of Science. Today we'll start with exercise 1.2 of chapter number 1 sets. Now exercise 1.2 consists of objective questions. So these are the questions that can be asked maximum up to 1 mark only. Okay, so let's start. So question number one is which of the following are example of null set? Okay, so set the first question is set of all the natural numbers divisible by two odd natural numbers. Okay, so the numbers which are divisible by 2 are 2, 4, 6, 8, right? These are the number like 2, 4, 6, 8, and so on. But all these number are even number, right? And what is our question? Our question says odd natural number, right? So there is not a single odd natural number which is divisible by 2, right? So as there is not a single natural number, this is an empty set, or I can say a null set. Okay, so let's put a tick mark. This is a null set. Okay, now second question, set of even prime numbers. Okay, so prime numbers are 2, 3, 5, 7, and so on. Now see, we have one prime number, that is 2, which is even. Out of all the prime number, we have a prime number 2 that is even. That means it is a singleton set, right? It is a singleton set. It is not a null set. Okay, so we will put it at a cross, right? This is not a null set. Instead, it is a singleton set. So this is not a null set. The third one, x such that x is a natural number, x less than 5 and x greater than 7. If I take less than 5, the number must like 4, 3, 2, 1. But there is also another condition, that is x greater than 7. Now if I take x greater than 7, then it will be 8, 9, 10, because it's a natural number, right? But it is and, means the number must be both less than 5 and greater than 7, and there is no common number, right? No common number, so it is a null set. Okay, so let's put a cross. This is a null, sorry, let's put a tick. This is a null set. Okay, fourth one. Y such that y is a point common to any two parallel lines. Now, if I just take example of any two parallel lines, it will be like this way. Okay, these are the examples of two parallel lines. Now, we know that parallel lines never intersect. So that means there is no common point of intersection. So it is a null set. Okay, clear? So let's put this also a tick. Okay, so the first one, set of odd natural number divisible by 2, null set. Even prime numbers, not a null set. Natural number less than 5 and greater than 7, both null set. And a point common to any two parallel lines, null set, because there is no common point. Okay, now let's go to the second question. Which of the following set are finite or infinite? Right? Finite set means in which we can count the number of elements, whereas infinite means we cannot count the number. Okay, so I will write down finite f, and if it is infinite, I. The first, the set of months of a year. Of course, there are 12 months in a year. We can count it from January to December. 12 months, So this is a finite set. So let me write it down. F. Second, 1. See, it is given like this: 1, 2, 3, dot, 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 dot. Means there is no end. If you can say that the maximum number is 1000, I will say the next to it 1001. If it is 10,000, the next to it is 10,001. 1 crore, the next to is 1 crore and 1. So there is not an end to this. So this is an infinite set. Okay, so I will write it down. I. Okay, the next third one: 1, 2, 3, dot, 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 99, 100. So there are total 100 elements. That means I know, right? That means it is a finite. I can count it. So this is a finite set. Okay, the next, the set of positive integers greater than 100, 101, 102, 1000, 10,000, 10,001, 1 lakh, 1 crore, 100 crores, 101 crore. So there is not an end, right? So this is an infinite set. But see, if the question is set of positive number less than 100, positive integers less than 100, then definitely it will be a finite set, right? It will be from 1 to 99. Clear? And the fifth one is the set of prime numbers less than 99. Of course, the lowest prime number we will say it as 2, right? 2, 3, 5, 7. Clear? And the last one will be 97. So of course there are prime numbers. It is a finite set because we can count it. So it's a finite set. Clear? So this was about question 1 and question 2. Now let's move to question number 3. Okay, question number 3 is state whether each of the following set is finite or infinite, right? This question is similar to question number 2. So the first is the set of lines which are parallel to x-axis. Okay, see, if I draw here this as y-axis and this as x-axis. Clear? Then I can draw 1, 2, 3, 4, 5, as many number of lines parallel to x-axis, right? This is x-axis, so we can draw infinite numbers of lines parallel to x-axis. So I will say this as an infinite set. Okay, so let me write it down as I. Second, the set of letters in English alphabet. Of course, this is a finite set. A, B, C, D up to Z. There are 26 letters in English alphabet. Means that is countable. So that is a finite set. Okay, let me write down F. Next, the set of numbers which are multiple of 5. I will write it down 5, 10, 15, 20, and so on, right? So there are infinite numbers of number which are multiple of 5, right? So this will be an infinite set. Okay, I. Third, the set of animals living on the earth. Now there are many animals living on the earth, so many, but I would not say it as an infinite number, right? So it is a finite set. Many animals, but still it is a finite. So I will write it down F. And the set of circles passing through origin, if I draw y-axis, x-axis. If this is origin, I can draw this circle. I can draw this. Actually, it's not a perfect circle, but I can draw as many circles as I want passing through origin, right? so I will say this as an infinite set. The set of circles passing through origin, that is infinite. Okay. Now let's move to the fourth one. In the following set, state whether A equal to B or not. Now what are equal sets? If the number of elements in both the sets are same and the corresponding elements in both the sets must be same. Means in set 1 it is 1, 2 and 3. Then in set 2 if it is 1, 2 and 3, then only they can be said equal set. Okay. So now let's see the first one. Okay, A equal to A, B, C, D and B equal to D, C, B, A. In both there are four elements. In A there is A, B there is A. In A there is B, B there is B. In C there is C, B there is C, and in D there is D, B also there is D. Means all the corresponding elements are same. Yes. And number of elements are also same. Four, right? So yes, they are equal. Okay. Second, A equal to 4, 8, 12, 16 and B equal to 8, 4, 16, 18. Now see, number of elements in both are same. But in set A there is 12, but in set B 12 is not there. So corresponding elements are not same, so it is not equal. Okay. The third one, A 2, 4, 6, 8, 10 and B x is a positive integer and x is less than 10. So in that case set B will be equal to positive integer less than equal to 10, positive even integer. So 2, 4, 6, 8. Okay. So this is set B. Okay, if you will say in set A it is 2, 4, 6, 8, 10. Okay, it's equality. So I will also write it down 10. Okay, so now when you compare both the sets 2, 4, 6 and 10, 2, 4, 6 and 10, that means both are equal sets. Okay, so let me write it down E. Okay, just a minute, let me erase that. Okay, now these are equal set. The fourth one, A x such that x is a multiple of 10. That means 10, 20, 10, okay, 30, 40 and so on, right? But here there is an element 15 in B, but in A 15 is not there. So these sets are not equal. Okay, so I will write it down and E, that is not equal. Okay, so this was about question 3 and question 4. Now let's move to the next question. Is are the following pair of sets equal? And if it is, then give reasons. So in question 5, first it is given A equal to 2, 3 and B is x such that x is a solution of x square plus 5x plus 6. Okay, so let me note it down. A is equal to 2, 3 and for B I need to solve it, right? It's given that x square plus 5x plus 6 equal to 0. So I will solve this equation. X square plus 5x plus 6 equal to 0. Okay, so when I will solve it, I have to split it in such a way that the product x square and 6, sorry, the product will be 1 into 6, that is equal to 6, and the summation will be equal to 5x, right? So I will split it into 5x into two parts, that is 3x and 2x. Okay, 3 2s are 6 and 3x plus 2x will be equal to 5x. So let me solve it. X square plus 2x plus 3x plus 6 equal to 0. So now I am taking x common. So it's x plus 2 plus 3 common, x plus 2 equal to 0. That means x plus 3 and into x plus 2, this will be equal to 0. So this shows that either x equal to minus 3 or x equal to minus 2, right? The value of x is either minus 3 or it will be minus 2. Okay, so I will write down b as minus 3 and minus 2, or minus 2 and minus 3. So see here, A is 2, 3 and B is minus 2, minus 3. Okay, so that means both the sets are not equal, right? So the question is, are the following sets equal? I would say no. Okay, they are not equal. Clear? Now let me erase it. The next one, second, A is equal to X such that X is a letter in the word follow. So when I will solve it, I will get A equal to F comma O comma L. Okay, second L I will not write second time. Again O I have done and W. Right? Remember the definition of set. Okay, elements enclosed in a curly bracket separated by a comma. Okay, now b equal to y such that y equal to y is a letter in the word wolf. So b w comma o comma l comma f. Now both the sets have four elements. In both there are F, L, O, W. So both are equal sets. Yes, right? The first one is not an equal set because the elements in A and B were not same. And second one is equal set because the number of elements are same as well as the corresponding elements are also same. So second are equal sets. In question 2, A and B are equal sets. Okay. Next, question number 6. From the sets given below, select equal sets. Okay. So now, in first, A is 2, 4, 8, 12. Okay. B 1, 2, 3, 4. So A and B are not equal because 12 is not there in B. C 4, 8, 12, 14. Okay. 14 is there, but 2 is not there in C. Okay, so C is also A, B, C, all three are different sets. Set D 3, 1, 4, 2. Right, 3 is neither in A nor in C. Right, but 3 is there in B. 1 is there in A, D and B both. 4 is also there in D and B, and 2 is also there. So I will select B and D as equal set. Now E minus 1 and 1. Clear? Whereas G 1 and minus 1. So say there is only change in the position but both are same. F O, or in F it is 0A, in H again it is 0 but it's 1. Right? So from this set B equal to D and set E is equal to set G. Clear? So these are the equal sets B and D and E and G. Clear? So this was about question number 6. Now let's see the solution of complete exercise. You can note it down. Okay, these are question number 1 and 2. Just note it down. Question number 3 and 4. I means infinite, F means finite, E means equal, and NE means not equal in question number 4. Next, question number 5 and 6. Okay, students, so that's it for today. In our next video lecture, we will start with exercise 1.3. Thank you.